Alright, here's our last examples from 11.5. They're also games, but I just thought I would separate them out so none of the videos got too long. So here we're going to toss a fair coin 3 times. Um, I guess we're tossing 3 individual coins, and it's going to pay 15 cents for 3 heads, 5 cents for 2 heads, and 1 cent for 1 head. So let's talk about what could happen as these 3 coins get tossed. The outcomes in terms of the heads that are there could be all 3 are heads, could be just 2 are heads, could be just 1 is head, and it also could be that none of them are heads. Now, probability is the next factor that we could look at. So what's the probability that when you flip a coin 3 times, all 3 are heads, or 3 individual coins? So we want 3 heads. So out of 3 flips, we want 3 to be heads. Okay, so that means the probability of a head is 1/2. I need that to happen 3 times. And I need this to happen no times, right? The tails, right? This represents heads. Let me talk about what this is. That first one represents heads. This one represents tails. I don't want any tails, just heads. And so what does that work out to be? C of 3 is going to be 1. 1/2 to the third is 1/8. 2. Probability exactly 2 are heads. C of 3, 2. I need 1/2 to be there twice. And I need the tails, right, who's the second one, to be there once. So C of 3, 2, I believe is just 3. Let's just make sure about that. Yep. And so it's a 3, and then this is still going to be 1/8. And so we're going to get 3/8 here. To get a 1, probability that it was a 1 is C of 3, 1. 1/2 to the first power, 1/2 to the second power, right? 1 head, 1 tail. And so as I do that, that 3 C1 is going to be 3 times, again, 1/8 is going to be another 3/8. And then the probability that none are heads is going to be, out of the 3 flips, I want none to be heads. That means 1/2 is to the 0, and 1/2 tails wise is to the third. That's going to be another 1/8. Okay. Notice that the probabilities, if we were to add them right now, all total up to be 1. That's an important thing, right? That's what should happen if every event's been counted for. Okay, so let's remember the question. The question wasn't what's the expected value for number of heads. It was the expected is 5 cents a fair price to play. So we're going to have to get the expected winnings, and then we'll use that. So let's find the expected winnings. So I'm not ready to do that yet because I haven't put the winnings in. I put the x times the p of x, but that would be the expected number of heads, which isn't the question. The question is about winnings and fair prices to pay. And so let's look at what we win. If we roll a 3, we get 15 cents. I said roll a 3. If we get 3 heads, we get 15 cents. If we get 2 heads, we get 5 cents. And we get 1 cent for 1 head and 0 for the last. And so now let's look at the winnings. So this is 15/8. And this is 15/8. And this next one is 3/8. And this last one is 0, just so you can track it with me. So 15 times 1, 15 all over 8. 5 times 3, 15 all over 8. 1 times 3, 3 all over 8. 0 times 1/8, 0. And so what do we have to do? All we have to do to finish out is to take the sum of the x times the p of x's. That will give us the expected winnings, and then we'll compare that. So that's 15/8 plus 15/8 plus 3/8. Well, that's 33/8. I'll put the plus 0 for emphasis. 33 divided by 8 is 4.1 $4.125. So maybe we'll put $4.13. That's our expected winnings. Now, I put dollars, right? It's not dollars. My mistake. Everything was in cents. This is 4.13 cents. So, is it a fair game if it costs 5 cents to play? The answer is no. This is not a fair game. And because it costs more to play. Now, what's the more to play? It costs you 5 cents to play than the expected winnings. So in the long run, you're going to lose money. And that's a good thing to be aware of. So the last example that I found and wanted to give you a picture of is this one. 20,000 raffle tickets are sold. There's one first place prize of $1,000, 2 second place prizes of $750, and 3 third place prizes of $300 will be awarded, with all winners selected at random. If you purchase one ticket, what are your expected gross winnings? Okay, so some things could happen. You could get a first prize. You could get the second prize. You could get the third prize. Or you could just get no money. Right? You didn't get any one of the prizes. So let's think about that. If you get the first prize, you get $1,000. Second prize, you get $750. So now we're talking money. This is great because that's what they want. Third prize, $300, and if you don't win any of those prizes, you get 0. Now, probability of each one of these happening. To get the first place one, there's only one option out of 20,000. To get the second place one, there are 2 second places, and there's 3 third places. So there's only really 5 tickets that are going to win. So 3 out of 20,000. That looks like a 3. 3 out of 20,000, 2 out of 20,000, 1 out of 20,000. Where did I get 20,000? It's the number of raffle tickets that were sold, one of which is going to be the first prize one, 2 of which are going to be second, and 3 of which are going to be the third place one. So if you look at 20,000 minus 5, there are 19,995 tickets that are not going to get any prize. And so, how do we find the expected winnings? We just follow the formula. 1,000. I'll keep my same procedure. 1,000 over 20,000. 750 times 2. I don't trust myself doing that, so I'm going to grab my calculator. 1,500 over 20,000. 900 over 20,000, and 0, right? So how do I finish? I just add up. So I take my 1,000, add to that my 1,500, and add to that my 900, and I get 3,400 out of 20,000 would be the expected winnings. So what's 3,400 divided by 20,000? 0.17. My expected winnings are 17 cents. So what does that mean? It means that if they charge me $1 per raffle ticket, I'm going to, the majority of people are going to lose, right? And we already knew that, but they're going to pull in 83 cents. So the raffle organizers pull in 83 cents for every ticket. That would be what they would expect to bring in profit-wise. So that's 83 cents times 20,000. So that's $16,600. That's how much they would make running that raffle, right? Where they make some people happy, right, with $1,000, 750, but a majority of people, right, 19,995 are going to walk away or empty-handed if everybody just bought one ticket. Okay, but 17 cents is the expected gross winnings. So if you can convince them to charge less than 17 cents per raffle ticket, it's worth your bet, right? You, in the long run, if you were able to keep playing this raffle, you would make money. So it's set up in a way for, as all raffles are, for the institution that's giving them to make some money. But now you can get a better idea of how much they make. So just checking to make sure there wasn't one more problem, but these are actual homework problems, so hopefully they'll be very insightful